Now let's look at graphing sine and cosine functions. So if we fill in x being the radians that we're talking about measuring with sine or cosine, and then we figure out the sine function for each one of these, how do we graph them? Well, we have the y-coordinate and the x-coordinate. The x-coordinate is going to be what we plug in for x. That's our independent value. Then we have our function, which will be our dependent value of sine of x. So sine of x can go all the way up to 1 and all the way down to -1. So if we plot this out, these are all of the different plots that we found when calculating sine of each one of these radians. And again, we're going with radians because radians is the exact length of the circle when the radius is 1 that we're moving. So this is another look at what we're graphing here. As we go up to 30 degrees, which is pi over 6 radians, we go up to 1/2. We go to 45 degrees, we go up. We go to 60 degrees, we go up. We go to 90 degrees, that's as high as we're going to go because sine of 90 degrees is 1. After that, it starts going down. Similarly with cosine. We have x equals 0, cosine is 1. We found that out when we were looking at the unit circle. As we continue to plot, the values go down. They go all the way down to -1 when we get to pi, and then they go back up. Now, if you graphed these continuously as long as you possibly could, you would see they would just keep going up and down, up and down, up and down. That is what is called a periodic function. So a periodic function is a function for which a specified horizontal shift p results in a function equal to the original function for all values of x in the domain of f. So what that's saying is if we moved this function over and we started this over here, it would just keep continuing. And then we can take this whole thing again, add it again. It'll keep continuing. This period is 1 revolution of the circle. Every time we go around the circle, it's going to continue to go down and up and down and up. So that's what a periodic function is. It's a repeating function. Again, 1 revolution of the circle going from 0 to 2 pi is 1 period. That's the sine function. For cosine, it starts at 1, goes down to 0, and goes back to 1. So sine is 0 to 0, cosine is 1 to 1. The period and amplitude of a sinusoidal function, y equals a times the sine of bx, a equals cosine of bx. The period is 2 pi over the absolute value of b. The amplitude is the absolute value of a, which is the vertical height from the midline. In addition, the absolute value of a equals the amplitude equals 1/2 of the maximum minus the minimum. Don't worry if you don't understand that off the bat. We're going to be talking about that some more as we move forward here. So, if we look at the original sine of x, the sine of x is in orange. So what it's saying is, when we look at multiplying x by a number, the period is going to be 2 pi divided by that number. So we multiply x by 1, 2 pi divided by the absolute value of 1 is 2 pi. That's how long our period is. What if we are looking at this function right here, sine of 2 pi, or 2x, got pi on the brain. Then we have 2 pi over the absolute value of 2. Really? The absolute value of 2, which is going to give us pi as our period. So now when we multiply x by 2, our period is no longer 2 pi, it just goes to pi right here. That's our period for our blue squiggly line. What about if we divide x by 2? Now we have 2 pi over the absolute value of 1/2. That's simply equal to 4. Oh, I don't know why I'm trying to write it 2. It's 4 pi. As you can see, we only have one part of the period of this one. It's going to go down way over here and not come back to 0 until it hits 4 pi. So that's what we're talking about with that b value. It's going to change the period. Whenever you multiply the angle portion, the period is going to get longer or shorter. The amplitude is the vertical height from the midline. So the amplitude is going to be how wavy your line gets. So if we look at our blue value, 1 times sine of x means that it's only going to go up to 1 and down to -1. Up to 1, down to -1. Now if we multiply it by 2, now our amplitude goes all the way up to 2 and down to -2. Now we're multiplying the outside of the function, not x, just the outside. Again, if we multiply the outside by 3, it's going to go up to 3, down to -3. It's going to change the amplitude of our function. So when we have something on the inside, we have sine of bx. It's going to change the period. It's going to make it longer or shorter, and it's going to change it by 2 pi over the absolute value of b. Absolute value of b just means if b is negative, that guy is going to be positive no matter what. When we're looking at the amplitude, we're looking at what we're multiplying on the outside of the trig function. So a times sine of x is going to change the amplitude. Or if that's easier to remember, the height. B is going to change the length. And it's going to change the height based on the value of A. And it's going to be based on the absolute value of A. So if we multiplied it by -4, it would still go down to -4 and back up to -4. It would just look like this instead. A little wiggly, but I think you get the idea. When you change, when you use a negative, it just completely flips it upside down, but the amplitude still changes the same amount, whether it's positive or negative. All right, it's getting complicated. Variations of sine and cosine functions. Given the equation of the form f of x equals a sine b of x minus c plus d, or f of x equals a cosine b of x minus c plus d. Whew, that's a lot. C over b is the phase shift and d is the vertical shift. What the heck does that mean? Let's keep looking. So what we're saying here is instead of multiplying, now we're adding and subtracting. On the inside of the parentheses, notice that it's a subtraction sign. On the outside, it's addition. So I just wanted to point that out. So when we are subtracting pi over 4, we are moving it to the right pi over 4 places. So when you see subtraction on the inside of the parentheses, it's moving to the right. If you see addition, it's moving to the left. So let's look at this closer. We have sine f of x, or f of x equals sine of x. This is our normal sine function that goes up and down that we talked about at the beginning of this video. Now, when we subtract pi over 4, the sine function moves to the right pi over 4 spots. Right here, that's pi over 4. Right there. So that's how far it moved over. Now, what if we subtract pi? Now the function moves over pi places. It starts right here instead. It moved over all the way over there. So you see subtraction on the inside of the parentheses, it moves to the right that many places. Addition, it moves to the left that many places. Now, let's look at the midline. The midline, when we looked at all of these functions that we've looked at so far, the midline, the line that cuts the graph straight in half, has always been at 0. 0 cuts all of these guys in half up until now. So this is what happens when you add to the outside of the parentheses. You will move the midline up that many spots. So you cut the graph in half, that's where your midline is. That's how far you move up when you add outside of the parentheses. Let's look at an example here. So we have the normal y equals sine of x right here. Now if we add 2 to it, the midpoint, the point that cuts the thing right in half, moves up to 2. With sine, with both of these, the original midline is going to be 0. So we start at 2 now because sine of 0 is 0. Move up to 3, down to 1. Our midline has shifted up 2 because we added 2. Let's look at some more examples. So this is basically a rundown of everything that we've talked about so far. Given the function in the form f of x equals a times sine bx minus c plus d, identify the midline, amplitude, period, and phase shift. So the amplitude is always going to be the absolute value of what's being multiplied on the outside. The period is always going to be 2 pi over the amplitude of what's being multiplied on the inside of the parentheses. The phase shift is going to be c over b. Note that c is negative, so c over b. In all of the examples we've looked at so far, b has simply been 1, so our phase shift has been c. But we'll see some examples where that's not the case. The midline is going to be d. All right, let's get to some challenging stuff here. Determine the period of the function f of x equals pi over 6x. So the period, let's look up here. The period, p, equals 2 pi over the absolute value of b. What is b? b is what's being multiplied on the inside of the parentheses. That is pi over 6. Absolute value of pi over 6 is pi over 6. Now let's use our rules of multiplying and dividing fractions. So we get 2 pi over 1 times, multiply by the reciprocal because we're dividing. Our pi's are going to cancel out. We get a period of 12. What is the amplitude of the function f of x equals negative 4 sine of x? Is the function stretched or compressed vertically? So let's see. Amplitude. The amplitude is the absolute value of A. A is what's being multiplied on the outside of the function. So the absolute value of 4. Absolute value of -4, which is 4. So what's happening? Is the function getting bigger or smaller? Is it getting larger like this? Or is it getting smaller like this? Well, the amplitude is increasing to 4, so it's getting stretched. It's getting bigger and bigger. It got bigger, I should say. All right, some more fun stuff here. Determine the direction and magnitude of the phase shift for f of x equals sine of x plus pi over 6 minus 2. Whew, what? All right, phase shift. Phase shift is number 3. It is c over b. C, remember with c, it's subtraction. So this is actually going to be a negative pi over 6. B is equal to 1. So how do we do this again? It's c over b. So it's negative pi over 6 over 1. So it's negative pi over 6. So the magnitude of the direction, or the magnitude is just the length. So the length is pi over 6. The direction is it's going to be moved to the left. Because when we subtracted, it moved to the right. When we add, it's going to move to the left. So it moves pi over 6 to the left. Determine the direction and magnitude of the vertical shift for f of x equals cosine x minus 3. All right, vertical shift. What does that say? Well, there's nothing that says vertical shift. But when I think vertical shift, it means that the entire graph is either moving up or down, and that matches with determining the midline. So y equals d. D is -3. So the vertical shift is going to be -3. Now what does that mean? That means it's going to move down 3. All right, determine the midline, amplitude, period, and phase shift of this function. Whew. All right, let's do the midline first because they ask for it first, and it's not that hard. So the midline, if we look up here again, the midline y equals d. D is +1, so the midline is 1. How about the amplitude? Let's look up here again. The amplitude is the absolute value of A. A is on the outside of the sine function. A is 3, so the amplitude is 3. How about the period? Let's look up here again. The period is P, which is 2 pi over the absolute value of B. B is on the inside of the sine function. So 2 pi over the absolute value of B, which is 2, equals the period is pi. How about the phase shift? Let's see, phase shift is c over b. C is what we're subtracting from bx. We are subtracting nothing, so it's 0 over 2, which is 0, so no phase shift. Ooh, this one's going to be fun. Determine the formula for this cosine function. All right. So let's look at this. We know that we need to know these different things: the midline, amplitude, period, and phase shift. So let's list that out. So let's figure out where the midline is. So the midline is what cuts this graph in half. The midline is at 0.5. The amplitude is how high the graph gets. The graph is, so the amplitude is how high the graph is from the midline, which is again 0.5. The period is how long it takes to get from the start of one to the start of the next. That is 2 pi. The phase shift, well, this is a cosine function. Cosine of 0 is not 0. Cosine of 0 is 1. So the phase shift, it moved over a quarter of a pi. Oh, I'm sorry, it moved 1 pi over. So the phase shift is pi. So let's see how we can put this back into our formula. So the midline is D, so we just add it to the end. The amplitude is A, we multiply it to the beginning. So we have 0.5 times sine of something plus 0.5. So this 0.5 went here, that 0.5 went here. So what about B and C? What can we do with those? Well, determining the phase shift is C over B, so we're going to need to know B in order to know C. So let's do the period first. Period is 2 pi over B. So 2 pi over B equals 2 pi over x. Well, 2 pi equals 2 pi, so x equals B. The period is always 2 pi in these normal circumstances, so the period B is just going to equal 1. Then we have to figure out the phase shift. Phase shift is C over B. B is 1, so the phase shift is just going to be what we saw here, pi. And we have to remember to subtract pi. And that's going to be our answer. Let's do another one. So we need to figure out the midline amplitude period and phase shift. So let's see if we can figure out the midline here. So it goes up all the way to 1, down to -5. So if we go up 3, that's going to be in the middle. So our midline is at -2. What's our amplitude? Our amplitude is how high or how low we go based on where the midline is. So it goes up 1, 2, 3. Our amplitude is 3. What's our period? Let's see. We start at -5. We go down and we go up again and reach that same point at 1. So that is 1, 2, 3, 4, 5, 6. Our period is 6. And our phase shift. Well, This one's a little bit more difficult to figure out because we're not sure if we're talking about sine or cosine. But let's pick one, because there are actually technically two answers to this question. Let's say that we're talking about sine. Then the midpoint would have to be here. So it moved to the left about 1/2. Now, if we had chosen cosine, we would have had to have moved this over, and that's where, well, actually, I think the phase shift is closer to 1 than 1/2. It's hard to tell when I can't draw straight lines. So -1. All right. Well, let's pretend this is cosine, and we'll call it +1. So our amplitude is going to be 3 times cosine of something -2. So how do we figure out b again? Let's see. Our period is 2 pi over the absolute value of b. Our period is 6, which is 2 pi over b. Let's solve for b. Multiply both sides by b. Get 6b equals 2 pi. Divide both sides by 6. We get b equals 2 pi over 6, which is the same thing as pi over 3. So the thing we're multiplying x by is pi over 3. Now what is our c? Let's see if we can figure out how to do that again. Our phase shift is c over b. So what was our phase shift? +1. So 1 equals c over b. Multiply both sides by pi over 3, and we get c equals pi over 3. And that is our equation. Look at problem 9. Feel free to look back in your notes as much as you need to go through these problems. I actually find these kind of fun, as I'm sure you could tell by the inflection in my voice. So if you have any questions, reach out to your instructor. They will definitely be happy to help.